All right, so we're recording. Awesome. So the fun thing, more with strings. What I want to reiterate to the class and everyone who's ever going to watch this, the whole 6 of you or 7 of you, maybe. um, Strings are the thing, and you're going to hear this throughout IT. String is the thing. Uh, Most data comes in some type of string format. Some of it's encoded, some of it's encrypted, but at the end of the day, data is some type of string. It's an object. So all these methods that you're learning throughout this chapter, how to split, slice, strip, indice, join, all this fun stuff, it rings true not only for Python, but other formats, other seams, other languages. They all have these methods that allow you to manipulate string objects. And it's super important. Like, and I'll tell you why it's super important. This is the why, right? Data is like a gold mine. If you could find facts and data or trend data, you could take that data, create knowledge out of it, maps, graphs, all kinds of fun stuff. They can be interpreted in crazy different ways. Trending analysis, you could do anything that's at your fingertips with data. If you think about it, you could say from this date to this date, how many of XYZ were put in the cart on my web app, how many were sold, how many were sold at a discount price, how many were sold last minute, how many put them in the cart but then removed it. So you could analyze something like crazy all through data, all through strings. That it's an amazing field. I don't know if you heard about data science. Pretty big, pretty huge lately. But just keep that in mind. Like this is it's a simplistic, very repetitive type of lesson, but it pays dividends like mad, right? So let's take a look. Group exercise. Everybody ready to dive into the group exercise?
For sure.
Let's tear it up then. So there's a couple things. We're going to write a pirate translator, right? There's tons of ways to do this, but we're going to do it with what's covered in the class up until now. Obey capitalization and punctuation. We might get to that. We probably will towards the end. Import a random R. Throw R in there occasionally. Remember to use the tools in the arsenal. Replace functions your best friend. Blah 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 blah. Cool. It depends on how you want to attack this. Let's talk design methodology. So there's many out there. There's two that come to mind: bottom up, right, or top down and bottom up, right? So you can look at this and go, okay, 1 is 1, 2 is 2, 3 is 3. Those first 3 requirements. I'm going to start at 1. I'm going to do 2. I'm going to do 3. Top down, right? Do my main requirement and the other ones. Some folks will look at this and be like, well, I know how to import random R. I could do that really quickly. They'll do the bottom up type thing. They'll do the things that are more like obscure, or maybe it's quicker for them. They'll get those out of the way, and then they'll come back to the main function later on, or the main meat of the program. It doesn't matter in my experience which ones you do, top down or bottom up. It doesn't really matter. What matters is that you hit all the requirements, right? And in agile programming, a lot of times this 1, 2, and 3 will be dispersed out between 6 people. 2 people work on each, or 3 on one, 2 on this, and 1 on the other. It all depends. In reality, it's you can light it up however you feel, right? I've been doing this a minute, so it's fun to do it differently. But I'm gonna take one first. Let's convert certain words, and let's read it out loud. We have to change certain words and convert them, or replace, right? So hello becomes ahoy. All right. Hello becomes ahoy. Hi becomes yo ho. Well, let's start coding this really quickly, right? But I'm going to pull up a notepad actually in Notepad because some people like to work in separate. I'm going to dump it in Notepad. I'm like, okay, so I'm just going to grab one. And we know that hello has to become ahoy. Well, in order to do that, I'm just going to do a test variable, and it's going to be hello there, right? And that's fine. Doesn't matter. Doesn't matter if that's even the right there. Who cares, right? Let's just do test variable. We're good to go. Let's use replace. So in order to replace, well, what do we need to replace? Well, we need to replace test, right? So it'd be test dot calling the method, the string method of replace. And I'm basically saying test replace hello with ahoy. Okay. And I'm going to save this. I'm going to save this as I'll throw it on my desktop. I'll save as L5 group lab. It's good enough. I'll hit F5 on that, and you don't get anything back because I didn't print it, right? Well, let's output it, print, test. Well, it's still hello there. Why is it hello there? Anybody know? Anybody know? What do you think? Print dot replace. Okay, I could. Or if I want to keep my normal, can I call it new equals and print new? And then I could print test to see my original. Totally, right? You can do print dot replace. I love that. It's quick and easy, but what it doesn't give you is an object to manipulate further if needed. Now, test string, okay, call on test dot replace hello with ahoy, store that new output in new, and print it. Okay, it's kind of cool. But now you have this new object that you can manipulate again and again and again and again, and still keep your original. So why don't we just call that original? There's nothing wrong with calling an original input or original message or OM for original message, something that you know, right? And save it F5. Oh, didn't work. Well, I called on test. I didn't change. There we go. See, so these little accidents are going to happen. Now, why I took one and did it really quick is to see what I could replace either with Python to use replace and do this, or you could just use find and replace. So becomes turns into something, right? Now becomes could turn into this right here. You could format or edit, replace, becomes, do this, replace all. And now you have some of your code sort of done. We'll wait on this one. We'll come back to that. So we're getting there, right? And then the front of this, we could probably just grab this and then just come here and go, okay. Well, I don't like that original because we have equals new, right? So the first time the thing that you want to replace, let me put that H back in there. The first time that you want to replace something, you store it in your new variable. And then instead of calling on original all the time and going through replacing everything, you could just call on new. So it'll look something like this. It'll be like new equals new replace, right? So now we have this going on for us. Well, the cool thing is you can start to do some crazy stuff like this. Let's see if this works. Yep. This making sense to everybody so far? And like I said, we could have used Python to do this, but I just want to show you a comfortable way. You might have to negate that, right? Exit it out. A comfortable way on how to use Notepad or another new file within Python, something to get you going, right? We don't need that. I think we need them all, right? And now we got this right here. And then hello there, and we could say, my friend is Steve. So I'm showing you a different way to design. So now, hello there, my friend is Steve. That's the original. And now with new, ahoy there, me bucko be Steve. But you notice something's kind of wrong here. You changed hello to ahoy, but you notice how there's spaces and I didn't put them. That's kind of a bummer, right? I made a mistake when I copied. I should have put a space after all this fun stuff. Little things like that you notice. And now here, ahoy there, me bucko be Steve. So it's kind of cool. What happened to there? Why didn't that get changed? Why do you think? Well, it's looking for there with a space. And here I have there with a comma. Right? So now we're going to run into weird things like this, like, well, it doesn't match perfectly. Well, okay, it sort of matches, but we could break this down into a list and then rebuild the entire thing, but we're not there yet. We're not looping through lists yet, right? And let me just go back here and show you what's up. So in the course lessons, lesson number 6 is lists, tuples, and string manipulation. The reason that we're not breaking this into just splitting on a space and storing it as a list is because it's a little bit more advanced and it takes the focus off of how to manipulate a string and more on how to manipulate a list, which is an object too, which we'll learn next week. But the whole thing is here is to hone in and really polish your skills with all the methods that are covered in this lesson. It's going to be very difficult to do some things. So you have to make some design choices with what we know so far. Do we do it? Do we not do it? Do we add it? Do we not add it? Do we tell the user we're not doing it? Those things are okay right now because we don't know every way how to solve everything. And for those of you who don't watch this video, who won't hear this, is that's okay. You don't know how to solve everything yet. That's fine. We didn't get to that lesson. You didn't cover that in the book yet. We will. This exercise, it's beautiful to read ahead. Not everybody has that kind of time, I understand, and we're realists, right? And you see those YouTube videos, learn Python in 4.5 hours. Go ahead. We'll see how much you learn and how much you retain. This is not a race. It's a marathon. The point of this lesson is to master the methods on how to manipulate a string, not how to manipulate a list, not how to manipulate any other types of objects. Focus on the string. It's okay if you can't do everything. We're going to learn how to do everything later on. Focus on these methods. They're lifesavers. Trust me. I'd rather have someone know how to use in and replace better than how to use a list because it's a level of expertise, right? So just be patient with yourself. So this is kind of cool. Can I do print, test, replace? Yeah, sure. But if I ask you to give me back my original input, can you? And if you keep printing something, you're not passing an object along. You're reinterpreting the entire object and running replace every time, kind of brute forcing. It's one's more elegant than the other, but they're both not perfect, right? They both have their ups and downs. I like building new objects and passing that object because I still have my original, but now I have something completely new, right? But we're not done yet. This is very elementary, and quite frankly, I don't like it, right? Like, oh, yeah, but there's 1,000 ways to do this, so don't. So do it within your skill set. Do it, master. Take the time to master these methods. I'm serious. The split, the strip, and we may not get to them all today, but it'll leave you prepared to how to do it in the future in your individual lab, which we'll talk to at great length, right? So let's just do this. Define main right out of the gate. Open, close. We'll pass on it, right? And let's just call this define replace original original message, OM, right? We'll do open, close for now, and we'll tab all this over. We may not want to gather this here. We may want to write a function that gathers. So define gather input, open, close. Okay, I like this, I like where this is going. Input, open, close. What is the message you would like to translate? Question mark slash n/t. I like that. All right, we'll get rid of all this. Zip. Hello there. Goodbye. Well, let's take a breather here. Well, we need some kind of welcome. Well, we'll go up and write a welcome function, or we'll do hashtag welcome. We'll get to that, right? Well, gather input collects the original message, which I'll just put OM for short, original message. Input, what is the message you'd like to translate? OM, well, let's just put message right here. And instead of original, I could have just used original, but instead of that, we're just going to use message. So now, when we call on gather input, it's going to return OM into something. Well, let's do that right here. Let's call OG message, original message, equals gather input, open, close, right? So gather input should run, ask us what we want, store it in OM. Well, we have to return it. So let's return OM. OM will then be stored in OGM just to change it, right? You don't want to use the same everywhere. And now replace OM, we'll call on replace OM and have it call on OGM, and it'll run its thing and then print out when it's done. Think it'll work? Don't need pass anymore. Any comments so far? Excuse me. Let's take a look at that before I even run it. So I just took what we did and cut up into two things, right? The message itself is Hello there, my friend is Steve. I don't want this. I don't even need this line anymore. Delete, 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 delete. I like that. So in theory, is that cool? I don't need this either for an original. We ready? Yeah, let's light it up, huh? Clean it up a little bit. So now we define main, we define gather input. Yeah.
Oh, sorry. I realized my mic was been turned on. I was like, man, this guy is not responding to me.
Can't hear you, Logan.
Um, um, so where's your original? You're taking in message while you're calling it message and replace OM. Um, to make my mind understand it more, you're really calling on OM as your parameter.
Actually, I'm really calling on gathering input.
Yeah.
Oh, correct. It will be OM, but OM is returned into OGM.
Yeah.
OGM is passed to this function as an object, and then replace OM uses OGM to replace message. It's just a
Okay.
variable holder. Now, a lot of people will name them the same thing, only cause problems because you can't pass the same variable name all over the place.
Noted.
So some people actually do like X, X1, X2, X3, right? Whatever gets your mind right and how to pass an object from start to finish. But I like to call original message. We gather original, we store it in original gangster message because it's funny. And then we paste that original gangster message into replace the original message, which actually performs a replacement, right? So gather does just that. It gets the input. Replace does just that. It replaces it. But yeah, that's a great question. And it's more of a design thing and a choice than anything. And now we run it and we have, what is the message you'd like to translate? My friend Steve is cool. Be bucko Steve, be cool. Okay. We're making headway, right? I did it as a single phrase translation. If input equals hello, print replace needs fixed. That's fine. You can do that too, Eli. It's no big deal. The whole point of this thing, though, is I'm gonna beat you folks to death on this. Python is objective. You have the opportunity to build all the objects you want and store them in memory. Use it. The methods take action and perform tasks to object types. This is going to set you up in the future to build your own objects with your own types of methods to take action on your own types of objects and methods. Right now, we're just using everything under the hood that Python has. Strings, integers, lists, tuples, dictionaries. Well, what if there's an object that you need to make that doesn't exist in Python? Which we will cover in lesson 8. The more you get familiar with passing an object between functions, the more your mind will open up. And when you work with computers at scale, like in an enterprise, you won't think of a computer as an endpoint. You'll think of a computer as a digital entity where these policies are applied to it. Policies are nothing more than a collection of rules set by a method to push to that computer to change how it reacts. A single server could be a DNS server one day, reboot it, apply a new setting. It could be a domain controller, cloud server. Excuse me. You can spin up whatever you want. You could spin up a cloud and it'd be a DNS server today, a web server tomorrow. It doesn't matter. It's just an object that receives. What does it receive? It receives directions to do other things to take that object and make that object do something else. A method. Ansible, the garbage they use in I can't remember the name of it, they use in the AWS and Azure to build everything. Terraform, Ansible, Terraform, all these objective type of management tools. they're nothing more than dealing with objects. The more you can wrap your mind around, I'm building these rule set to apply to this object type, the better you will be in system administration, cybersecurity, dealing with data. And that's it. Get away from this one line does one thing, like print this, print that, print that. No, do this for each object in my objects, print this. Right? Get used to dealing in bulk, get used to dealing with objects. That old school mentality of like one line does one thing is very batch script and very bash script, which is fine. There's a time and place to use those. But at scale, dealing with object types, you can get more done. Does that make sense? Is that kind of? I'll say that 10,000 times before we're over. But anytime you get a chance to make an object, do it. Right? A PowerShell is the same way. I never use the PowerShell objects that are returned to me. I build custom objects because it allows you to make a new object, which is basically a variable with like dot notation, which is the same thing that we're doing here. So get comfortable with objects and pass the object around. You'll do this at scale when it comes to users, groups, permissions, ACLs, access control lists, devices, router configurations, and files themselves. Treat them as objects, not as one thing. And you'll get really used to messing all this up. So let's look at the requirements here. I think we got the message sort of replaced. I'm sort of happy with this, right? Sort of, but we're missing a couple things. Well, now we have these other things, capitalization and punctuation. I haven't tried those yet. How can we tackle those?
Dot lower, capitalize, dot upper, or the upper method, that kind of thing.
Well, how do I check if it's capitalized?
You would do OM dot capitalize parentheses parentheses.
Let's take a look. Is lower? I like that. Because you said is capitalized or is lower?
Now thinking about it, there is no is capitalized unless you wanted to do the index of the first letter in the
Well,
string.
I like where you're going. I like where you're going with this, though.
Yeah, so you would do is upper on the index of, let's take 0 for the first letter.
Mhm.
And then if you really wanted to get specific, you would have to see the message first, but you would just have to get the index of the first, the first letter. Let's just start with that.
Right, my friend Steve. We could just do it, write a test message, right? Let's get rid of this. It's a beautiful thing, right? So we got my friend Steve as a test message. And if I want the very first letter or first object in that string, the first string in the string, or first character of the string, I'll say that. You just call it first string equals test square bracket 0 square bracket, right? Because now I have this object of first string that I could test with, and now I could print my first string. And now it's an M. Now I could test first thing for things. And we could just do this print. We could test F string for dot is upper. Can't remember if I need parentheses after that or not. Well, we'll find out.
I think you need parentheses.
Yeah. Good call. I always don't remember that. So we get a true back. So now we have a Boolean check is upper. But think about this. That's really going to stink. Do I want to do it before I replace or after?
I think you would want to do it before.
This is where it gets tricky. If we say like hello turns into ahoy, so the H is removed and there's an A. So we can't do things like my and me is what I'm saying, right? If it starts with a capital M, cool, save it, change it, you know? So now it's almost becoming this whole, man, we might have to tackle this a different way. Is upper true or false? How about we just stick with that? We don't have to care what the letter is, because if we change from hi to yo ho ho and we just have the true that it was upper, can we come back and change hi to yo ho ho? Let's do that better, right? Let's test it. So now we get a true and H. So now we can start adding logic here. We could define check cap, right? Open, close. And then how do we check it? Well, it's upper. But we have to do everything we just did here. So
I was
yeah.
gonna say, could you use the find tool to like find the part of the string that has an uppercase character and or something that I'm not sure.
Well, the beauty of this is it shouldn't change someone's name. Like if it's Bob or Doug and it's capitalized, because we're only grabbing those strings and changing them. But if we find hi, like if we change this and find, if we decide to take that test away and go back here and go, man, what happens if my first word is a capital hi? Does it change to yo ho ho? Does it?
No, it doesn't. It just prints yo ho ho.
Well, no, it print hi, right? Capital HI.
Oh yeah, you're right.
What do I do here? Let me do my pass.
The point of doing it is to
There's more to it than you think, right?
Yeah.
Look at that. Let's not worry about this right now. Let's focus on the problem at hand, the hi. The hi never changes to yo ho ho because capital HI. So now we have to check if it's capitalized, change it to lower, perform the change on the entire message, and then put the capitalization back if capitalization was true. So now you get this conundrum of, man, I'm sure glad I have my original message and my new test message, because from this, let's walk the dog on this, right? You define main, you run gather input, you gather some input, right? You return OM, your original message. Perfect. Your original message gets passed to replace message. Then you start to do your replacement. Well, there's a couple things we could do beforehand, right? So we want to return something now. I'm going to leave it print here, but I'm going to comment it out, and I'm going to use return new and then a comma. And my goal is I'm also going to return my original message. Just follow me on this, because now I'm passing objects all over the place, and it might make my long-term job easier. So we're going to return new and return message. I'm going to have to store those in something, two things to print them. And I'll just store them in new message and OG message equals replace message, right? So now once this runs, new will go into new message, message will go into OG message, and then I can print them accordingly. however I see fit. And there's tons of ways you could do this, but this is just running you through some design things here. So now that I have this message, let's live right here in its originality, because the original message is passed to replace OM, and message is now my original message. Can I do something a bit different here and say, well, message will equal message.lower? What will that do?
It'll make everything lowercase.
It will. And then you can go ahead and do your changes. So hi should become yo ho ho and all this stuff, right? All this stuff. Let's see if it works. So my point is this becomes a bit more difficult than at first, right? Let's stick with our hi motif. Hi, Steve, my friend. We'll just throw some words in there. Oh man, not defined. New's not defined. New M's not defined. It's getting all mad here. So where's it mad? Line 17. Where's line 17? Right here? Print new, you're right, because it's new M. I messed that up. 51 is 50, 48, 51. Okay, so let's talk about these tracebacks, right? First one that kicked off was 51. Well, yeah, my main function had to run. Within that main function, my next error is on line 17. So line 17 was where I just had new, and it says that new wasn't defined. My bad, new M. Just always start at the top, but look at the last lines and look at the line numbers. It'll help you out a lot. Let's run it again, right? Same thing. I'm gonna put hi, Steve, my friend, right? Yo ho ho, Steve, my friend. So the new message got transferred to yo ho ho, and my original is still hi, Steve, my friend, but it's lower. So at what point in time should I check for capitalization before I lower the message? Does that make sense? Because once you lower it, there's no capitalization. So does it make sense to capitalize here?
Yeah, because
Or
that's before you turn it lower.
it is. Do I even want to bother with an individual function called capitalization? Or do I just want to do it raw in the function? This is a choice that you'd have to make in design. Okay, let's just say we're going to do it right out the gate, right? So we have our message, right? But I want to add logic. First thing I got to do is make my first string equals message index 0, right? We got to gather that first thing. And I'm not going through every word. We could, right? But iterate through everything to check if it's upper and all this stuff. But that's lesson 6 with lists will make that a lot easier. You can do that here. Your code will be 10 miles long. It may not be worth it. So let's just obey capitalization for the first word, right? Easy as that. But like I say, if you capitalize Bob, it'll stay Bob. Well, until you lower it, right? So now we're getting, do we want to lower? Because if I put a name in there, like, hi, Steve, well, look what happened to Steve. Steve got lowered. Dang it. Do I have to check every letter if capital? That would stink because you have to save every one. And then there's going to be losses, is what I'm going to say. You can sit this and beat yourself up and write this 10-mile long code that you think is perfect, but it may not be. And that's okay. We'll learn how to fix it in the next lessons. This is a build on build exercise. But this is a give it your best shot, right? We're going to show an effort. And here is going to be our effort for capitalization. I spelled that right. We'll go with that. All right, so here's our, here's our first string. We got it. And now we got this whole if statement, right? If first string is equal to what? Can I put if first string dot is upper? Will that work? Is it that easy?
Wait, what's first string again?
First string is the message first character. So whenever I type it in my message, it should grab the first string, the first character in that string, and then store it to check if it's capitalized. So just the first word. Like hi in this case. Right? Let's
So
just see.
I
Yeah, hey,
have a wild idea. This
Yeah,
might be really
let's go.
complicated,
Why not?
so I'm trying to figure out basically what we're trying to figure out. And I was thinking, what if we split the strings? Like what you type in, that way you have each word individual, and then you can like loop through the list
Mhm.
because it turns it into a list, and then you loop through the list if the first word in each part of the list is capitalized.
Ah, you're getting it now. You're getting that me dropping that list motif early off. Really heavy, wasn't I?
That's the only thing I could
Yeah.
think of, but I thought it might be too complicated.
It's not at all. We're going to walk the dog here, how painful this is, and then we're going to go to your list idea. Because it actually becomes more difficult. Well, not difficult, just different to rebuild a string after you have a list.
Yeah. Mm-hmm.
But you can. It's really not that bad. And I think it's like end equals separator or end equals nothing. So you could build it really easy. But this is where everyone goes to first. Usually they don't think about an object. They think about the strings being a string, and that's fine. This is the ultimate way to master these methods, is to rip it apart and look at every character.
Yeah.
Often good to know how everything works, and it's a necessity. But like you mentioned, sometimes a list might just do the trick, right? And we're going to walk through both. It's going to be funny because both are right. One's cleaner than the other, but one is more objectively thinking than the other. Sort of. At the end of the day, you're going to realize you're messing with the same strings. But I like where this is going, right? And we're going to do that. We're definitely going to end up there. But just humor me on this, right?
Do they both use loops then?
Oh, they're going to. They can.
Okay.
They can. This is like a make-believe loop, right? This is just looking for every word. If the word's not even in there, it just leaves it, right? It just looks for this word in this string and replaces it wherever. But that's not really looping at all. It's basically saying replace hi. If hi in new, replace it with yo ho ho, right? It's not really a loop at all. It's just passing one object to another and re-looking for something to replace. Your loop method is a little bit more tricky, almost. It's almost too easy, but we're going to get there. And I'm glad you pointed that out. It's usually this early in the game, usually nobody points that out. So good on you for knowing the material, right? So where we're at right here, let's go back to this real quick and then we'll dive into that one, right? Where we're at right here is we grab our message, peel off the first indice, we do a check to see if it's upper. And right now I just did this a test. So print cap, it says cap, right? Well, if true, it'll be true. So you could print something like, oh, notice your first letter is capital. You could interact funny with the user. It could interact. You don't even have to print anything here. You could say else, nothing, else, nothing. You don't even need an else, right? But we'll just do that, no cap. So we have the first thing. We got this. So how would we deal with that first object? What do we want to do now that we know that the first letter is indeed upper? Just think about it. We got it. It's uppercase. Do we want to change it now or change it later? How would we? You see what we're getting into here? A conundrum.
Yeah, we would have to change it after it's lower to do message index 0 dot capitalize parentheses to capitalize the first index after we lowered it.
Exactly. So now we're doing first string is upper, right? And we move this object, right? Because message will still be message no matter what. Or will it? Nope. We need to gather the first string first. Change it all. Check if our first string is upper. If first string is upper, then we got our new, right? So then right here, we go new first string equals new, right? You follow me on this? Or can I just say if first string upper, new equals new dot upper, but that changes it all to upper. Capitalize, right? Is that a thing? I always forget if it's capitalized or capitalized. Let's follow logic on this. We pass our original message. We gather the first string. We save it. We change the entire message to lower. That way, it'll catch high, change it to yo ho ho, or things like that. It'll go ahead and change the message, store it in new. We have our first string. If first string is upper, new equals new capitalize, which will capitalize the first thing, and then pass back new. Else, we'll just print no cap to the screen just for now, right? Want to try it?
Do it.
Notice first vessels cabin. We'll save that. Yo ho ho, Steve, my friend. Hi, Steve, my friend. But this, the replace and print OG message, what happened?
It replaced yo ho ho as the capitalized, not the message. So you would have to do message equals message dot capitalized.
What do you mean? No, I'm right here, right? We're talking right here?
Yeah, your capitalized method changed yo ho ho, but not hi, my
Perfect.
friend.
Well, you're right, because we stored the capitalized H. We lowered the entire thing. We changed hi to lowercase yo ho ho. First string capital H is capitalized. So now we took our new, which is lowercase yo ho ho, and made it capitalized and pooped it out in yo. So this is how we got that right there. Steve is a casualty of war at this point. We lost capital S.
No, I was under the assumption we were trying to get hi to print back out as a capital H, not yo ho ho, as a capital yo ho ho.
Well, both, right?
Yeah.
But in reality, my OG message is wrong, right? Because I returned the message, and the message has been augmented, changed to lower. So in reality, I don't need this at all because I have my original message in this. And now when I save this and hold on, let me undo that. Save it and run it. These are all these design flaws, right? Hi, Steve, my friend, right? Man, I'm having a rough time with friend tonight, right? Oh, what happened there? Blah, 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 blah. 56 calls on 16. What's 16 at? 16, where's 16? Oh man, I didn't need that, right? So all these little tiny things that we've changed along our design, Python yells at us and reminds us, hey, you removed this, but you didn't remove it everywhere. So now we get our original message back as designed. Our yo-ho-ho was changed, verified that we had our first capital, if capital, capitalized the new string. So yo-ho-ho from lowercase goes to capital. It's working like a boss. Cool. It's working in this scenario. We'd have to work through every word and everything to see how it would end, right? How do we deal with punctuation? Any idea? Last string? -1? I'm cool with that. What test could I do on last string? What test could I do? Any idea? Is alphanumeric? It's not punctuation if it's alphanumeric, correct? If last string is alphanumeric, print no punctuation found. Else, but here's where we go to last string. What do we do here? We gather it, right? First string is upper. Are we checking the right place here? Would I have to strip it first? Last string, alphanumeric. This is false. Right, so what do we do? What do we do with last string? What if I straight up just did this, save this, ran this? Why'd it keep it?
Because it never replaced anything. It just kept the original string.
Yeah, so we lost friend turn into bucko. So that kind of stinks, right? So now this whole message changing the word friend, if this has to take place somewhere else, it has to take place up here. Order of operations, right? Because now we're going to strip the string if string is alphanumeric, no punctuation found, else now we have message is equal to message. Now, how do I strip it to start from the beginning and go -1? Anybody remember? Start at 0, end at -1. Will that work? Because now I'm saying start at 0, stop at -1. So that's my new message. But now I also have my last string. So now we might have to do this twice. Once to remove it, right, and create the message. Let's see if this works. What do I do here? Cancel. Now, correct me if you found a different way to do this. So here we get our new message. Does everything as designed. It finds it. It strips, hi, Steve, my friend, stores the exclamation point and last string, performs the message to lower, does all the replacements, checks if upper, replaces it if necessary, right? You got the Y there, so it's working. Now, do I have to do this again? Got to put it back somehow, right? If last string is alphanumeric, okay, print no punctuation found. Else, what do we call here? We call it new.
I have a question.
Yeah.
Why are we throwing exceptions for punctuation if we just keep the punctuation in like normal? Like if we don't change it?
Okay, but you didn't change friend. Friend is supposed to be changed to bucko. Requirements are a son of a gun, huh?
Wait, what do you mean? What do you?
Yeah, replace if in your original message, if you find the word friend, change it to bucko. Well, Steve's my friend, exclamation point. Friend is there. Exclamation point's punctuation.
Here's a question.
Oh, is it because friend has a
Punctuation. It's a
space
string.
back
Yeah,
there?
well, the space too will get you too, right? This is somehow programmatically we either have to remove the space. Well, then befriend will turn into be bucko. Ah, see, so different words will be changed when you don't want them to be changed. And leading words will change. If I come in here and try to solve this by putting a space in front of friend and removing this one, well, now friend's the first word, it won't ever be changed to bucko. This is a loaded gun. Is what I'm telling you is there will be casualties. There will be things you cannot change in this with what we know up to date without making your code 10,000 miles long. You have to make design decisions. At what point do you go, man, this is too hard? At what point do you say, it can be done, I'm going to do it? At what point do you say, here's the instructions. This is the pirate translator. You can only end in exclamation point, question mark, or period. You can only start with a capital letter. You see what I'm saying? Is how do you want to design your solution, and where are you going to decide to go? I can't do that right now, but I'll get back to it, right? Or maybe never. There has to be a point of good enough because you'll end up tearing your hair out. Now
Trying
there is
to be perfectly specific, yeah.
Yeah, but what you said by leading with strip or split may be a winner, but not entirely. We're going to have problems with that. We're going to try that next, right? This is just
Probably
the
with
first hour.
punctuation or cap. Yeah, punctuation.
Both. You're back in the same arena, right? But being objective, you could check everything for that. And when you want to deal with it, when you want to deal with punctuation, is up to you. And when you split stuff, it's easier to do it at the beginning. And I'll show you that, right? But it was just my personal opinion. It's easier to do it at the beginning. So with this monstrosity we're building, which is awesome, right? We're using everything we learned up till now. We got our functions in place. We got return statements, all this fun stuff. We're learning that, okay, we're going to have to rebuild this. If last string is alphanumeric, no punctuation found, else new equals new plus the last string to put that punctuation back that we stripped off the top, right? That we removed. So we could actually put a comment here. If punc remove and store. Man, that V is quick. And here we can add a comment. Restore punc if needed. Now all these can be turned into functions, right? We could do this, and then we could run these functions however we want. Restore, repair, rebuild words. You could turn these all into separate functions and functionalize this entire program. We're doing a decent job of it so far. Say hi, Steve, my friend, exclamation point. Now we have it rebuilt, even with my misspelling. Not happy, I want it to be Bucko. Syntax, will get you, right? That's funny because some dude today at work was having a problem. And I walk over, I'm like, oh, I need a space there. Put a space there, it worked. I'm like, fresh eyes, man, fresh eyes. I'm like, syntax. Then later this afternoon, I had an issue. I'm like, dude, check this out. He's like, oh, man, you missed the caret over here. I'm like, there we go. So it's always better to have perspective, different eyes. So now, why did it change? What am I doing wrong? What's happening here?
There's something wrong with the stripping. Maybe it's not leaving you a space after friend.
Yeah. Olivia alluded to it right away, because now you have this. Dang. I can't end with a hard return. So this is a nightmare. This is a lesson in intestinal fortitude, patience, learning how to solve problems, and what's the best way to do it. And the best way to do it is to go through the book, do all your challenges, and learn what works, learn what doesn't work. Now, could you write logic up top? And we're going to do this right now. If last string is alphanumeric, print no punctuation found. Else, message equals message 0 -1. So now I remove the exclamation point. Could I do this? Plus a space at the end? Ooh, I hate
Yes.
doing that. I absolutely hate doing that. Because whatever we add, we have to take away later. Now for fun, let's run it. Ooh, can't spell for anything, right? Okay, it looks like it worked pretty good, except it had that space there. So now we have to remove it down here. Right? Well, how do I remove it? Well, new equals new 0 to -1. Ooh, will that always work? Only if the last word is something that we changed. Or only if punctuation was found. Which one is it? Testing will tell. Right? So you save it, go back over here, you run it. And let's mix it up. Let's make sure we get hi in there in the beginning. Let's say, hi, Bert. You are my friend, right? Hi, Bert. You are me, Bucker, right? Okay, so that tested well, right? Lost the capital on the B, but on the Bert, but hey, man, that's acceptable, right? We could get tricky and just check for capitalization and leave the rest, but then Bert will never get changed, but is that really a big deal? I don't know. You know, it's these design things. And you can solve all these problems. We're not going to solve all the problems tonight because I want to show you a couple different ways how to do this. But one is that I really want to show you is main function, mainline logic, call on some custom functions, pass your objects around, deal with those objects as you see fit. Now, could you write a function to go replace first, replace last? Totally. If these conditions were met, you could turn this into a function, right? You could turn the rebuild into a function. You could do all that. You can solve this. And as a group, it usually goes by really quick. Like in real life, like in my real life classes, like I'll see the teams break up and each person on the team will be like, well, I got capitalization, well, I got punctuation, well, I got this, I got that. Online, it's a bit more difficult to do that. That's why I'm kind of setting it up and kind of going through it with you. Now, let's just say this is good enough. We'll just take this and go, okay, this is good enough, right? Olivia, what'd you mention earlier? What'd you bring up?
I'm sorry, concerning what?
Like lists?
Let me find it. The splitting method and how it automatically put it into a list.
Yep.
Splitting strings.
Now,
Yeah,
we know,
dot split.
I love it, right? Let's just run this without any mainline logic really quick. So we're going to define main, gather the input, store that here, and then we're not going to do this yet. Or this, we may never, right? But we're going to return our original message into OGM. And then we're going to split OGM by calling on our original message dot split, right? And then we're simply going to print our split original gangster message. 5, group lab 2. So what was the message you'd like to translate? Nice. So here's what we did. We took an original function that we already built for get input, used it, we're just getting input, got it, returned our original message into OGM. We split OGM, stored it in a variable called split, and now we have a list object in SOGM. So what do you want to do now?
Call on each item of the list.
Okay. So
or at
let's
least the first one.
let's just make sure SOGM. How come that didn't work when I typed it in there? Like, how come I can't print this?
Because you're basically printing like the list as a whole, right? Like not the stuff in the list, but the fact that it's a list.
Well, the proper answer is SOGM doesn't exist in the shell because it's just a local variable under main. It's not a global variable. If you create a global variable like var1 and have it equal test, And watch, I'm going to run this same thing. And I'm going to type the same message. I get, hello, Steve, my friend. But now, if I type SOGM, I get an error. If I type var1, I get test. var1 was loaded from global space into memory, and it's currently available in my shell. But SOGM is a local variable to main. Main ran completed. It is no longer available in the shell. That is another big difference between global and local variables. Isn't that awesome? That's super awesome. I know. It's amazing. But you could change that by doing a global variable called SOGM and having it print to it, and you could do that. But I just wanted to point that out because that it's gonna bite somebody, and I want everyone to be aware of. You're still dealing with scope, even though we moved down from lesson 4. Global and local scope are still a thing, right? So awesome, right? We got that. We talked about it. We're moving on. So we're back to square one where we have a list. So we need to replace some stuff. Well, luckily we already built a replacement whole thing, right? We built this whole thing. Do you think we need it all? How do you want to handle it? Because does all this kind of go away?
I mean, you still have to pay attention to capitalization, right? Well, eventually.
Yeah. Let's take our list first, right? So we got our list. We're going to pass it to this. I'm going to pass to replace. So it's going to take the place of message. So now we got a list here. Now, can we say for each word in message, will this work?
When you highlighted all of that, did you do Shift Tab to give it the tab all at once?
Did I? No, I just hit tab.
Just a tab.
Yep. So now let's follow this. Let's follow logic here. We're going to pass a list to our function. Our function is going to say, for each object in my list, perform word dot replace hello. Well, we're no longer replacing a string function. Does do a dir on list? It has append, insert, remove, reverse, sort, extend. Man, we're treading on thin ice here because a list object doesn't have a replace, but doesn't know it's a string. And could it work? Was the Python engineers that smart, right? Well, here's a trick, right? Well, for word and message, this won't work, or will it?
We can try and see.
Well, let's think about it, because we're going for each word and message. Is it easier than we think? Is it if word equals hello, replace with ahoy? Because we can't do this passing anymore, because new isn't a new phrase, it's just a word. Or, follow me on this. Or can we create an empty list and append to it and rebuild a sentence? How would you solve this with a list? Olivia, you sounded like you had a decent grasp on it. Did you get it?
I'm kind of trying to parse it now, but the only thing I'm thinking of right now is like,
You need a new object to add your new word to. Could you say in? And then in replace the indice? Well, let's take a look at this. So let's grab exactly what we're talking about. Let's just say this. Let's try it in the shell. And it equals this. Right? So now we have it in the shell. Could we say false? True. If true, now, follow me on this. How do I get the indice of that?
what do you mean? Like,
I need the indice potentially. It doesn't work that way, right? To find high. How would I be able to find? So now that I know that high is in here, how do I know to change it? Because the logic would have to go for each high, capital HI, in my message. If high equal to high, replace with yo ho ho. Or is there a simpler way? Ooh. Anybody know where I'm getting at? Do I need a list? So what if I change this to if my invar1 now you know where I'm going? Ooh, this is getting cool. What do we replace my with? I don't know. I'll put me, right? Ooh, see, but it's my with the space. Oh man, did I need to do any of that? Did I need to split it? You can. You could create a list like we did. You'll learn more about lists next lesson. You'll have to do things like for each word in Word, if word in this list. Ooh, what if I did that? What if I took all these, made our list? So what do I mean by that? Well, let's just say, go back to my notepad, right? That's easy to do. ending, go from -3, see if it ends in ing and change it. No big deal. Right, let's just take this and go, okay, cool. I want this. I want this. You see where I'm going with this? I'm building a list very poorly. Very poorly, I'm building a list. I'll skip sir, I'll skip there, I'll grab a couple of these. I'm not going to grab them all. You get the picture with the couple, right? What if we called this, what do we call it? It's called main words or something. Main words equal that. Can we do for each word in my message? Now we got an if, right? If word in main words, what do I want to do?
Is it like based on the position it is in the list? Change it to.
Well, now you're going to see a list isn't the best. A dictionary is where it's at. So now we're learning more and more into lesson, the next lesson 6, right? Because what's a dictionary? Well, a dictionary looks a lot like a list, except it ends and starts with curly braces, and it has what you're looking for, also known as the key. Not necessarily what you're looking for, but you could use a dictionary to do this. Hello would be ahoy. Well, hello is the key, and the value is now ahoy. So now you have a key value pair. So let's just keep this a very simple dictionary. And let's say hi would be yo ho ho. This is lesson 6 stuff. I'm glad you brought it up. I'm looking for more using the methods like we did the first time with replace and all that fun stuff. This is where you're getting to. And this is next week's lesson. And this is a dictionary. So when I do things like go back to my shell, and I'll call it dictionary 1 equals this. Syntax. What does it need? It's the colons, right? Full colons. Phil Collins, like the artist. I can't stand Phil Collins anyway. So now we have this dictionary with a key value pair. The key is hello, ahoy. So now we're getting into this thing of, oh man, I forgot how to do this. Man. Take that value. No. For each key value in dictionary 1, print value. Trace back, was there too many variables to unpack, too expected? So what did I do wrong here? I don't even remember. My syntax is wrong on the dictionary. But you're going to see next week what you're going for here is you're going for a dictionary. Like you find that lists are inferior, you could do it. You're going to beat yourself up, trying to kill yourself. Then you're going to go, oh man, 2 lists. Well, hello is the value or key, and I want to turn it to a ahoy. Well, the next lesson is going to be as simple as if value equals key, change it to value. So we're getting that far ahead of ourselves, right? You're getting there. And I love the whole concept of a list. We could use a list. We could split it, turn it its own objects, write a for loop and say for each word in my word, if it's one of these, do that. But now you're just going to rewrite these and all these will be if statements. So for each word in my message, if word in or a list, or if word is equal to hello, like let's just do it the way we know how, like currently. If word is equal to hello, then you'll call on your message and replace this current word with hello. And you have to do that for each of these, which in essence is almost the same thing as writing it like this. Not saying it's wrong. I'm just saying it's more complex than what we need right now. And the focus of this lesson is string methods, right? So
And
yeah,
the fact that if you use the split method, it'll include the punctuation in with the word
yep.
in
But
the list.
that's pretty cool to do though, because you could do something like this. Let's do this again. I'm just gonna. All that's solvable. We just don't know how yet, right? So
Yeah,
I could do a length of SOGM, and I get 4. So I could call SOGM index of 4. Now watch this. There's nothing because the index starts at 0, 1, 2, 3. So now what I could do is I could take the length of SOGM, which equals 4, minus 1 to show me the last word or last item. To prove that, I can make a variable called last item equals the length of SOGM minus 1. But that won't give me the item, will it? Now, if I did this, ooh, that's thinking objectively. Because now I said from my list of SOGM, give me the length of the list, which is 4, minus 1 is 3, but now it's in an index. So I said SOGM index of 3, which is 0, 1, 2, 3, and now I have my last item. We're going to learn how to do this next week, but I just wanted to show you it's possible because you brought up punctuation. It'd be hard to tell. Well, now that we have the last item in the list, can I ask it if it ends in an alphanumeric or alphanumeric? What the heck? Can I see if it is alphanumeric? Yeah. If false, get it, right? Because it's punctuation. Now I know what you're thinking. I could always import string. And in string, there's this whole punctuation thing. Yes, there is another module that you could import to look at punctuation, but it doesn't really help you much. Stop me if I showed you this. I think I went over it last week. I always misspell this. I always type it wrong, punctuation. So string.punctuation has all your punctuation. You can grab the last thing, grab the last character in your message and say, in string.punctuation. It'll give you back a true or false, and then you could do your logic that way. I showed it to you in class. You're about to find it on the internet. You could use this. I have no problem with it. It's fine. It's part of the standard load of Python. But what I'm showing you is that Olivia brought up a great point of you split, make a list, go through the list with the for loop. Yes, I love that. I do love that. But we're not there yet. We know enough to be dangerous, but it'll just leave you with more questions. And then you'll get into a bad habit of using a list to check a list, which is nothing more than a dictionary, a key value pair. So and this is where you want to be thinking. This is how you want to be thinking. You want to be thinking objectively. So that's beautiful that you did that. I love it because it's worth a shot. And we got 50% of the way there, stumbling through it until we got to this point and said, man, this is getting kind of tough. It's out of our ballpark right now. Could you still do it? Yeah, totally. You could do it. I know you could. With a couple nested for loops, you could figure this out and you could be on your way. But the focus of lesson 5 is to beat yourself up and to master these string methods. Try except statements. What can go wrong here? What can go wrong right here? Gather input.
If you don't include any of the words that need to be replaced, maybe.
Yeah. Or if it's the
If they
wrong
try to
type.
put it, yeah, if they try to put in numbers, you could pull up an error for that.
Yeah, you'd have to write some logic to check, right? Is alphanumeric true, false? If alpha, if contains alpha, you'd have to write some logic to check that. Totally possible. But for now, let's just say they didn't input anything. And print error, right? Try, except, what is it? Something else finally, I think. Finally, print. Finally. All right, we're just going to run this. And this is just with gather input. This isn't with the whole script, right? I'm going to show you something. So, yeah, I want to translate. Enter. Okay, it broke. I entered nothing. It still took it, except never happened because it took my null message. And then it still printed my finally and my try except finally. Right? Which could be cool to say goodbye politely. Finallys are helpful. End of code, end of script. You could do stuff like that. But okay, this broke. Okay, we're just messing with this right now. But my point is, don't focus on these. We're focused on try except finally right now. So these try except finally are awesome when you're ready to accept what? Well, let's accept I don't know what's input. I forgot what's a wrong thing. Logic error, or you could type the value error. Value error. I'd be like, what's the value error? Let's say integer just for fun. See if this works. An F. Oh, finally. It all broke. Let's see. Value error. Did I spell it wrong? I think
You don't put it in parentheses.
We do.
Really?
Or did I misspell it? No, what do you do? I'm asking.
In the accept statements that we did, we didn't put it in parentheses. It just went next to accept without parentheses.
Was it space?
Yeah. Yeah.
Okay. Where's C? I'm not saying you're wrong, because I don't really use this stuff. No, I do, but not to this extent, I'll be honest. So let's say F, right? Okay, cool. So you're right? Pop my error. So what happens if I put it in parentheses? Ah, it worked too. Doesn't matter, you just gotta spell it right. The parentheses are here because in different versions of Python, you got to separate your value errors by parentheses, but now you can separate it by comma because they are to their own object now. So even your value errors and your tracebacks are objects. Isn't that cool? So let's throw 2 of them in there, hit save, hit F5, I'll do the same thing. F, I'm looking for an integer. I got finally, that's it. It didn't grab this one because this one happens outside of it. But you see my point here is if you didn't have the parentheses, this would still work. Oh, no, it wouldn't. Why didn't it work? Because I have multiple exception types. It has to be parenthesized. By default, my floppy scripting, I automatically put them in parentheses, but you can catch more than one type of error and catch them all, but they just have to be wrapped in parentheses. And Python's kind enough to tell you, which is pretty cool. But one by itself is rock solid, right? We already proven that. Now, you could try except finally any part of your code you want, anywhere you want, to include inside functions, inside your main logic, inside everywhere, when it makes sense. If there's no error to be caught, don't catch it. Usually there's errors to be caught, but do you care? Some errors could happen. Who cares? No big deal. Do I want to alert the user? It's up to you. This is where like all these design decisions come into play. And this is the difference between a scripter and a programmer. There are different levels, good, mediocre and excellent. Sometimes good enough is just fine. And I know that'll drive some people with OCD crazy, right? And it really does. But get over it. Most people will try anything in my code. If it goes wrong, put it in the wrong place. Print error. Now, this is one of the benefits of writing a main function. Because now instead of doing error correction everywhere, you could do error correction just in your main function. If that was your design, you can write error correction or error handling. My bad. You can write error handling anywhere throughout your entire script. It's up to you. You're the master of your own destiny. Does that make sense? I got error because I'm still looking for an integer. Gather input broke. Right? So now that gather input broke, I'm like, oh man, what happened? Oh man, I could fix that. Now we're back to square one. Don't go crazy with error handling unless you master it. It takes time to master it. Use it. Put it in your scripts. From here on out, I'm expecting at least one usage of error handling and one custom function in all your code forever, for until we part ways. It'll make you a pro. I don't care if you keep it in the same place and use it all the time. It's up to you. You designed your code. There's a ton of stuff to cover in this lesson. Take a deep breath. Use what's in the lesson. Accept where you're at, right? And move on. This is an awesome script that we came up with, right? We fumbled around with where we want to handle stuff. If we wanted to add new functions to strip and replace and do all this stuff, we decided to leave it and just replace. Not bad, because it sort of is part of the replacement function itself. Could you write a sub function to do capitalization and punctuation? Yes. It's up to you. It's a design. Be okay with getting on base this time, right? Use everything you can. It may not be perfect, but it's going to be darn close. Some of you are going to pull off a perfect one, and then I'm going to be like, so you found it on these 3 websites. What are these 3 websites? Like, it's more of a self-preservation. Can I do this myself type of exercise? Can I use what's in the lesson up till now? If I see people going out of bounds and using dictionaries and listing stuff that's covered next week, I already know where you're getting it from. Like, I've been doing this too long, right? And ChatGPT will give you certain things too, depending on what prompts you use. Some prompts are better than others. But challenge yourself, beat yourself up. Let's look at the individual lab. Individual lab. What is this? These are just indices, right? Index. Don't use order char. It is not a cipher. Don't use it. If you use it, you're going to zero. One of the requirements is don't use it. Why? They're not in the book. They're not covered yet, so don't use them. Literally, use what we just did and you will succeed. Right? Remember how to get the indice of something? How do you get the indice of something? Anybody remember? I'll pull up the notes. Let's see if I can find it. Indexing, right? Let me open it. Indexing is your best buddy. Where am I at here? Lesson 5. Whoop. So, banana, this is how you get the index, right? You call on the index to get it back. Length of fruit for each character and character end. This right here is probably a beast mode. This will help you a lot with your individual lab. Personal opinion. I think that'll help you. Does anybody remember how to get that index? Is it slicing? Is it in here? Anybody remember?
Index for what?
Say if I had a variable. I'll do a new shell. Say if I had a variable. Say if I had that. How would I get the indice for E?
I'm assuming without using car.
That's not an indice. That's a Unicode value for what we see as a symbol of R. It's not an indice. See, it's not the right thing yet. But we know E's in there. Does this work? I always see this. No, you can't. You got to slice with integers. How do I know where E is in here? How do I get this? How do I pluck that? Did we cover it? I know we did. I thought we did.
The find button or the find function.
How do I use it?
You would go. Can't remember if it's before or after. Okay, before dot var 1e.
So we're talking. Just walk me through it. What do I type?
I don't know. You put find first, so now I kind of want to put find first. But
we can do var1 find.
Yeah,
right?
And then parentheses, and then e.
Bingo.
And then you're gonna want to put a space in before the A to make it easier.
Maybe not. Let's go back to your lab where you're doing a Caesar cipher, right? Let's say if I said my key is 3. Okay, my key's 3. And my message is this. Let's go, this is cool, right? A, B, C, D, F, G, H, I, J, K, L, M, N. Oh, no. See, I did it again. We'll just do that. And then I'll do this. So I can go up there. I think it's Visual Studio or something. Okay. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. Where's V? V, X, Y, Z. Okay. Now I want to do a cipher. For each, I'll use character. No, you can't because it's a special word. For each item. Now let's call them what they are. for each letter in message. Oh, man. What can I do here? Okay. var1 dot find letter. Oh, how come it all said -1?
Is -1 like a false for index?
I put quotes around letter, so it's actually looking for the word letter, and -1 is false. You're
Okay,
correct.
yeah.
Now I got everything I need. That's my cipher. I'm done. This is cool is 19,7,8,18. That's for this. Well, how do I do that? It's not this easy. Does that almost look like your cipher?
Almost.
Almost. I'm not going to give you all the tricks, but for fun, let's take this to the bridge, right? So what this does is just grabs the indice from my variable and replaces t with 19. Okay, that's cool. That's sort of encoding a cipher, right? But I got this thing called a key. So can I do all this, but add a key to it? How would I add my key? Could I ask the user for the key? So if I say, excuse me, user, what key would you like to use to encode? And you said 7. And it added 7 to whatever the indice was. Then when we went to decode, you'd say, excuse me, user, what's the key you use to encode? 7. So it uses it to decode as well. Could you do that? Yeah.
I think so.
Yeah, it's just the indice minus or plus 7, right? You got find. Now you notice I'm not using a list. I'm not using any tricky object. I'm literally using a string with another string to find each character, which is a string. I'm finding the string in my string to get the indice, and then I could add my key to the indice to make a cipher. Not too bad, not too hard, not too difficult. So many people are going to create multiple lists. You don't need multiple lists. You don't need a list at all. All you need is your variable 1 or your alphabet. And you could even go as far as doing something like this. Let's see, var1, you can create an alphabet that has a space in it and all the capital. And all the special characters, because all they are indices. 26 space 27. 27 plus another 26 is what? Any mathematicians out there? 53? 53. So technically, if this was Z, that would be in the 55th indice or 54th indice. 53rd if we started at 0. You see what I'm saying? Some people like seeing their spaces be 0. So put it in the 0 indice. Pretty cool. So 20 now. It's 20. I didn't put the dashes in yet. 20 is really my T. THIS space 0 indice. Pretty cool.
It looks easy. Fairly.
How do you get those dashes in after every letter?
You put it in another loop. Let's loop it up.
I like that. Nested for loops. This may not be the answer, but it's part of it. Right? I'm not that generous. Not all the time. But this looks pretty good. Well, what if you remove this? Oh man, see, I keep thinking I'm in the code. What if you remove your end? Or what if you just did end dash, got rid of your sep? Ah, son of a gun. Now, what can you do to make this look? What can you do to make this look like this? What can you do to make it look like that? I just did it. You take your object, your new object, you remove -1. Right? You remove the last item in the string, remove -1. Then you literally look for -0 and you use the replace function and replace it with the space. And then you will get something that looks like this. You're welcome. If you find yourself, let's do Control Z here. Oh, my bad. If you find yourself backspacing the last item, that's a remove -1. If you find yourself backspacing a pattern, -0 -0 and replacing it with a space, yes, that is replace -0 with a space. What you do in the real world often mimics code. Isn't that crazy? Isn't that awesome? Pro tip, always, if you're unsure, take it to Notepad, adjust it how you would Notepad, and then go, son of a gun, I know those commands. I could do it with commands. Isn't that awesome? Did that take the sting out of this a little bit?
Yeah.
You know how many people won't watch this video to the end, and you know how many people are going to use char and ord because they didn't read the last line of the requirements. Do you know how many zeros I'm going to give out next week? Not from the 5 of you. Thank you. Now, can we get the other 75 on board? That's the question. We have any over-unders? Anybody want to bet?
Yeah. I got 5 on the over.
Oh man. So I'm gonna say I'll get a total of I'm gonna go middle of the range. I'm gonna say 15. I'm gonna say 15 folks will turn in char and ord. So you got okay, we'll go say 5 over under on 5. Okay. So 20 or but somewhere between 10 and 20. All right. So homework assignment, good bet. Just kidding. That's on recording, but for real. So this isn't that bad, right? Find, replace is your best 2 buddies. It's just learning that syntax. Object.find. In is your buddy. Gives you a Boolean true or false. Right? These are little tiny words, but they're super powerful in logic. In, find, object.replace. Replace this with that. And you're good to go. I have faith in you. Like I said, there's a ton of material in this lesson. Don't be overwhelmed. Use what makes sense. Find, replace, in are your buddies. Mixed with your for loops and your if statements, all that fun stuff we learned. Split is awesome, or replace on this. A dash is cool. Like you can handle it either in the beginning, turn your space into something, or turn your space into something. It doesn't make any sense to remove your spaces. It doesn't make any sense to split on your spaces yet, because that's next week's lesson. Master the string methods. You will find out that oftentimes it's easiest and best and not even to go to a complex object. Sometimes you don't need a list. Faster to do it like this. Master these methods and you're on your way to the next level of Python string manipulation. You're on your way to the data scientist. You're on your way to really understanding what data is. It's a representation of ones and zeros, which are strings, right? You got this. I'm gonna go ahead and stop the recording.